Hello, this is the second video about Möbius transformations, and it's about what we do if the pole is on the path followed by z, that is on the z locus. So here's an example. The z locus is still the same circle, mod z equals 1, but now the transformation is w equals z plus 1 over z minus 1. That blows up. It gives you dividing by 0 when z equals 1. So its pole is z equals 1, and that is on the path which z follows, the z locus. If we use the usual method, we get two z points in line with the pole, which is 1, the pole itself, and minus 1. So our W diameter ends are W equals 0 for this one and W equals infinity for that one, because we end up dividing by 0. Now, that is actually right in that what it tells us is that W goes to infinity. It isn't a circle, it's a line. And when we're dealing with these transformations, we regard lines as a special sort of circle, except they've got a centre to infinity and a radius of infinity. So, this is correct, except it doesn't tell us enough. It tells us that it's a line and it goes through the point 0. It doesn't tell us how it goes from 0 to infinity. To find that out, we've got to take one other z point and find another w point. Doesn't matter which z point, so just choose the value of z which is going to make your calculation easiest. Here I'm going to choose z equals I. So I will choose this point, z equals I. So I have another w point, which is w equals I plus 1 over I minus 1. And that is equal to I plus 1 times minus I plus 1 over 2. Sorry, minus I minus 1. And if you work that out, that will come to minus I. Okay, so we have another w point, which is here at minus I. So we now know where the w line is. It goes through 0 and minus I. It's the imaginary axis. And if you want to work out its formula in terms of the real and imaginary parts of w, we can do that just by knowing from what it is geometrically, which is given to us by that point w equals 0, this point w equals minus I, and the fact that it goes to infinity. In other words, it is a line.